Have people in here used Project Euler before for anything? I've started spreading the rumors that this is a cool site to use. So I think some people in 210 and 211 have started using it. I see at least one person nodding their heads, a couple people. If you've seen it before, you may have solved a few of these problems before, which will be okay, probably. But for the rest of us, we're going to start at the very top. These are just like you saw on the very first day of class. They are some problems. They're mostly just math word problems. And the idea is we're going to write a program that solves the problem. And if you register for an account, you can actually input in the field here to make sure that this ends up being the correct answer. You can get it verified. So the plan for the day is I'm going to set you loose. We're going to do what's called pair programming. You're going to find somebody who is near you, preferably someone you do not know. Introduce yourself. And the way pair programming usually works is you're going to have one person sitting in front of a computer who's responsible for actually typing the logic, and one person whose job is to think about abstractly, are we doing the right thing? And worry about the design, worry about the implementation, and help feed the person who's doing the typing some of the correct work, checking to make sure that everything that's being typed is well formed, is correct, is doing, it's kind of the voice in the back of your head, who's the voice of reason. So we'll start with what I think might be the easiest problem on Project Euler, and hopefully over the course of today, we can cover the first couple problems. But we're going to start out. I'm not going to give any direction to start, and my goal over the next 25 minutes or so will be to slowly start piecing this program together live in front of you. And I'm hoping that you are a little bit ahead of me over the course of that. But if you get stuck, then I will be able to help you out and make sure that we stay on the same page. And we'll try to finish this off within the first 25 minutes of class. So the problem says, if we list all natural numbers below 10 that are multiples of 3 or 5, 3 is a multiple of 3, 5 is a multiple of 5, 6 is a multiple of 3, 9 is a multiple of 3. If we add all of these together, we get 23. Continuing this process, what would the sum of all multiples of 3 or 5 be for all numbers that are below 1,000? So go ahead, find a neighbor, find someone you want to work with, and see if you can crank this program out. We are pairing up for pair programming for this. So hopefully there are an odd number of people in the class. If there are not, then maybe you two work together. Two. There are an odd number of people in here. It looks like there might be a group of 3 right there.
I can go over there.
Yeah, sure. That worked perfectly. And now there are an odd number of people again. Every time you think you've solved the problem. So we are currently pair programming. We've kind of grouped up and you've just become the new odd person in the classroom. So here's a generic programming problem. We're just kind of getting our feet wet, making sure that we are solving or are able to solve. It's probably a 210-ish level problem. It's not going to use any of the crazy tools from 211, nothing object oriented, nothing from data structures or this class so far.
So there should be only one class, there shouldn't be two different.
Yeah,
classes.
we're even just trying to get an answer to this question, because if you go to Project Euler and actually register for it, you would get the opportunity to, there'd be a text box down here. I don't want to sign in because I've solved this problem and it would show you the answer. But if you make an account, and then you'll be able to verify that you have the right answer from your program by typing it in. And then your account will be good for all, what, 800 and something problems that are on Project Euler? 874 problems? Hopefully someone else walks in so that you have someone to work with, but if you'd like, you can join any other group and make it a group of 3 so that you're not by yourself.
Let me join the login and create an account.
So.
Do you wanna program it first?
Why don't you both try? Let me just check if JGraphs works. I saw JGraphs and Intel. They have Intel both, so which one do I use?
My recommendation would be to use IntelliJ just because more classes moving forward are gonna be using it than use JGraphs. And any experience you get with IntelliJ is probably gonna be better. Serve you better in the future. Does anybody have any questions about getting things set up? Registering for an account? I guarantee they won't email you spam. I don't think I've ever received an email from them. Question?
How do we check if you have the right answer?
If you have an account, if you've registered, then there will be a text box down here with the ability to type something in. If you get a nice green check mark image, then you have it right. Go for it.
Yes.
Yeah, no internet. Ugh. I hate the internet in this building for exactly that same reason. Sometimes it works, sometimes it doesn't. It's okay, it's not like the building's only 3 years old or anything. Not 300 years old. Anyone think they have an answer yet? Were you able to check it and see if it was right? Nice.
Is this including or excluding 1,000?
If we look at the word below 1,000, how would you logically interpret that?
Excluding 1,000, I think, but let me correct that.
That is correct.
Okay.
We want to exclude 1,000. That's a very good point. I underline this as the most common mistake people make on this problem. Below 1,000 does not below and including 1,000. So we only want to go through 999, not
Good, just
1,000.
make sure to screw that out.
Yep, that's a great thing to verify. If you solve this problem and get that green check mark, go ahead and work on the second problem in the list of Project Euler problems. You got it? So if you actually go click the register button here up top. Give an email, then there will be a text box down right below the box here that allows you to type an answer. If the answer is correct, you'll get a green check mark, and then it will be permanently associated with your account.
Are you required to make an account or is it optional?
In order to check it, you need to make an account,
Okay.
but we're also gonna go over the solution here
Okay.
ourselves. So if you really don't want to, that's perfectly okay. You don't need to.
What do you have so far?
Yeah, I think what we're supposed to do is, like, talk it out together, and then so like, I'll be basically saying like what I think the logic of it should be, and then.
Yeah.
How have people started this? Before we even dive into the code, let's start thinking logically. So what logic have people used in this? Describing the problem in English, maybe. Yeah,
Using modulus.
using modulus, that seems reasonable, right?
Yeah.
Mod 3 and mod 5.
Okay, what kind of construct are we gonna use to make sure that we're able to get all of the numbers below 1,000?
I did a while loop.
Sure. While loop will work, for loop will probably save you a line or two. So what does that loop look like?
Are we doing a for or while loop?
We're gonna do a for loop.
Okay, for your variable int, variable equal, it, variable whatever it is. I do we start 0 or 1 for your I?
That's a great question. What, any ideas? Does it matter if we start at 0 or 1?
I think it matters a little bit. Probably.
If we're trying to figure out the sum of something, so let's start out our sum at 0. So first of all, is 0 a multiple of 3 or 5?
No.
It is. It technically is. 3 times 0 is 0, 5 times 0 is 0. If we were to add 0 to our sum that starts out at 0, does it change the sum at all? No. So logically, it is not going to matter whether we start at 0 or start at 1. In fact, it won't matter if we start at 2 or if we start at 3. Doesn't really matter. We can start at 1, that's fine. What should the termination condition for our for loop be?
Less than 1,000.
Yeah, I'm gonna say if I is less than 1,000, we will continue. And what are we doing each iteration of our loop? Incrementing I, great. Now we need to figure out if the current value of I is either a multiple of 3 or a multiple of 5 or a multiple of both. So I'm gonna leave this here for just another minute or two in case you haven't reached that far. Remember, if you have finished and have a solution and have that verified, feel free to go on to the second problem. I will catch up to you momentarily.
Wait, what's the most for again?
Huh?
Wait, what did you use it for?
The straight line bars.
Okay, so and is the,
Oh, yeah.
And it's the ampersand, yeah.
okay.
The trick that I use for that is ampersand is a strange word, but it's really close to and percent. So you can remember that the ampersand is used for and because it's similar.
So actually,
Okay, I think I'm done. The combined, I think it was equal for the total is, I want to add this to a total, right?
Yeah.
Okay.
We're just gonna find the total.
Yeah, I could. So what? I don't feel like we can count too lazy.
All right, can anybody walk me through this if statement that we want to use? I think we know we want to use an if because some of these numbers between 1 and 1,000 are going to be multiples of 3 or 5, and some of them are not. So we need some kind of branching conditional that's going to tell us for the current value of I, is it a multiple of 3 or 5, or is it not? Yeah.
If I mod 3 plus or equal to 0 and equal to 0.
Mm-hmm.
Or I mod 5 equal to 0.
Why does that work? Walk me through the logic of exactly what this code is doing.
It's basically checking if I in that iteration is it divides by 3 and 5. And if it does, it'll run through that if statement.
Yeah.
Doesn't it?
Yeah, so if we wanted to do something like map the value of I to the value of I mod 3, we could do something like make a table, we have I mod 3, we're starting I out of ones, we say 1, 2, 3, 4, 5, 6, 7, 8. I think that'll be enough to give us an idea of what's going on. What do we expect the values of I mod 3 to be? Shout them out and I'll write down whatever you say. What goes in this column of this table?
I think for the first one. I thought it was zero, but it's not.
It is not.
Asking for remainders?
Yeah,
Alright, 1, 2, 0. 2, 0.
great. So we basically see that this is an iterating loop of 1, 2, 0, 1, 2, 0, 1, 2, 0. And we see that for the associated rows where we have a multiple of 3, the value of I mod 3 is 0. So this allows us to say if the value in the right side of this table is 0, then this entire if is going to be true, right? Because if you have an or like this, either one side or the other just needs to be true in order for the whole thing to be true. So whenever we reach one of these rows, it's going to be true, and we want to enter the if statement to do something. How about if we added a row, column, one of these things for I mod 5? What would that look like?
1, 2, 3, 4, 0.
We would start 1, 2, 3, 4, 0, 1, 2, 3. So in addition, we are now grabbing this row because this value is 0. We're basically saying if one of these two columns is 0, we want to consider that number to be one of the multiples of 3 or 5. I always like to have some visual that I tie to whatever code that I'm writing. So if you are able to in your head, great. If not, it's worth drawing out something like this to just see what your code is doing, and it will give you a sense of, is this going to work? Yes or no, before you even run it and test it. Just do a quick gut intuition check and say, is this what I'm looking for? Yes or no? Questions about the table? Can I erase the table? Table gone. Okay, what goes inside the if statement? So we'll be entering this if statement if one or the other or both of these are true. What do we want to do if I mod 3 is 0 or I mod 5 is 0?
Sum equals sum plus I.
Perfect. Does everyone understand what this line is doing and how this affects the total? Make sure that the sum is going to gradually grow to be the sum of those elements of the table, those rows of the table where either the I mod 3 column was 0 or the I mod 5 column was 0. What's left to do in the program? That is handled in the for loop. If it were a while, absolutely, we want to make sure that.
Print it out or something.
We need to, at some point, print something out. Should we do that inside the for loop? Something like after the for loop. Once this loop ends, we know that I has reached 1000. That means that we are done. The value in our sum variable should contain the solution. So let's print. What should I print? Where's the solution going to be? Sum. We run this program and we get an answer. Is this the answer that other people have gotten as well? It's amazing that it did all of that work that quickly. If you think of it, the actual logic of running through line by line, the decisions that your program is making, it did that very quickly. If I were to add a 0 to this and do it for the first 10,000 numbers, how fast do you think it would finish? Done. Let's add another 0. How fast is it going to finish?
Probably pretty quick.
Done. Of course, we overflowed our integer, but. So you can see that computers are pretty darn fast at things like taking modulus and doing addition. Whenever you can phrase a program involving these simple mathematical operations, computers can do hundreds of millions of those per second. If not more. It's amazing. It's truly amazing. So if you enter that number into Project Euler, you should get a nice green check mark and you have your first problem solved. Let's go look at the second problem. The second problem, who here has seen or heard of the Fibonacci sequence before? Just about everybody. So terms in the Fibonacci sequence, it's gonna start us with 1 and 2. Some start with 0 and 1, some start with 1 and 1. We're gonna start with the first two elements of the Fibonacci sequence being 1 and 2. The sum of the two numbers of the prior generates the next one. So 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. And this process continues forever. This will ask us now to find the sum of all even valued Fibonacci numbers less than 4 million. So go ahead and write a program. You'll need some generic way of saying whatever the last two numbers are, figure out what the current number is, and figure out if the current number is even or not. If it's even, add it to the sum. If it's not, ignore it and continue calculating. Generate the next Fibonacci number. So again, give this a shot. You can use your same teams, but maybe flip who's doing the programming. Switch roles in your pairs.
We should start with.
We have to start 1 and 2, right?
Yeah, you should initialize the first values of 2 ago and 1 ago to be 1 and 2. However you want to create variables for that. I don't want to spoil too much in advance.
And just trying to figure out how to backward translate. That's the
Yeah.
hard part.
That is the hard part.
I have
You're
the
absolutely
idea.
right.
What do you think? Which
got-
one do you think?
We got start with 1, 2 variables. 1 is 1, 1 is 2, whatever 1 and 5 as. And then the output is good. The first value will always be 1, the second value is 2, and the third value beyond is keep adding the previous two numbers. Repeat the process over and over and over again.
Yeah. So how do you think we do that in programs? Do you think?
Yeah, we have to count, we need to count how many times you want to do it, that'd be another variable. I tried to make a new project, to do mail right now. I want to make a new file.
You probably don't even have to make it.
I want to keep it for a record's sake. Let me go back further. Can you do this assignment? According, I am trying to make this, trying to make a new program so well.
You need help making the program.
I want to make one separate from a separate file, a main file and then separate ones.
Do you have did you create a package for it?
No, I have this is for my main file and my main file on this one, it makes sense. For my own sanity. So you can see, I'm also from the 212, I want to make another file project, that's what I'm putting it.
One quick thing that I'd like people's attention for. So if people have seen me do things like type sys out and then do something that auto completes it. The similar thing in IntelliJ is for you to type, instead of sysout, just type sout, it's even shorter in IntelliJ. Just hit tab and it'll autofill out the system.out.println line. You shouldn't need to actually manually type that out ever. Sout plus tab, 5 key presses, so much faster and shorter.
Same, yeah, there's like. System and not that.
The first time I learned Java, so the very first programming experience I ever had was in C in Emacs on Linux. And there was just no shortcuts, not an IDE, it's just a text editor. It was gross, so I especially appreciate any time that you can make something shorter, make something easier. I mean, we're all computer scientists, we all appreciate that, but.
Okay, you should. Go start this point. It's really. Can I make it hard to
Get used to.
So we.
It says there are notes.
No, I'm just trying to work out the logic and.
Okay, so I guess I'll if I read it, I'll be, I got the idea. So, yeah, we use. So the idea is that we have a counter.
Wow, that, they wanna see how it's solved.
Counter that, because we use a counter of some sort, I mean, it's like. 2, 3, 5, we're gonna add p to the number. But we have to keep track of the number changing simultaneously. The first, the original was always, are you the I for one?
They're taking 211.
I changes, I change that to J, so every time you add I, you have to set I go to J, J plus I?
Yeah. Or.
You see where he's confused, yeah,
Faster than the
it,
program.
help me account, how many times you want to keep in process.
So I can actually do what
I
I
think we wanna keep it under 4.
Yes, but it's like what I wanted to use for it.
We just use anything.
Okay, let's call it free then. So our counter, and this guy is. We do 4. And
Oh, that's what we're doing.
for I, J, again, presume these are just applied.
We want- I don't know if you would use C in the full, actually.
We have it, yeah.
Yeah.
I set up a double.
Wait. Why would you use J? Was J keep going for a while? Like,
Well, Jay's gonna keep, we want Jay to keep incrementing too. But
Yes.
It's just gonna be hard because you have to figure out how to switch the values between, we'd have to find like a temporary value to do.
Oh, that
there's a
makes sense.
temporary value.
J, that makes sense, okay.
Well, what we're doing.
Okay, yeah, that makes sense. Okay, that makes sense.
And now we have to figure out how to, you would have to do like a switch, so we'd have to do something like.
Yeah, that's,
We'd have to do something like. Equal.
yeah, I agree with that.
That J, or we have to do like.
I equal, wait, J plus I,
It would have to be like, it would have to be 10 equals,
yep,
J.
yep. I agree with this.
And then we would have to figure out how to keep track of.
Temp is just temp, and for there, you can lose temp for there, and every time you do loop, you have to redefine temp. You have to. So. It.
So how are people thinking about this problem?
Equals I, J, whatever you want to do, I, you try to do loop, redefine it. Temp, J, and then the rest of this.
I absolutely love how much collaborative work I'm seeing. It's really nice. especially as you get to know more people, it's tough being in the Catalyst building and being so far removed from the rest of campus. I feel like it's important to get to know some of the people who are at the same level in the same program. So this is good. When we do this in the future, I'll have you working with some different people, just so that you get to know some more people who are in the class. But starting to think about this problem, how are we gonna go about it? Let's start in English again and not too much think about the exact code, but what does that process look like?
Templator, whichever, you should have some sort of templator display.
Anyone wanna walk me through it?
Yeah.
So what are you thinking? Yeah,
So I was thinking to start with two numbers, obviously 1 and 2. And then as we add them, then 1 and 2, 3. And then step back. Change number 1 to be number 2 and number 2 be the next number.
yeah, so kind of moving forward to the next iteration of the, and when we've done that work, we're ready to loop back around and check the next
Right.
number. Sure, I love that logic a lot. So we're inside of a loop. We need to check if the current Fibonacci number is even. If it is, add it to some running total. And then we need to prepare for the next time around. So we need to kind of shift everything backwards one. So what was 1 ago is now gonna be 2 ago. What was the current Fibonacci number is now gonna be 1 ago. And we can do some kind of calculation to figure out what the new current Fibonacci number is in preparation for the next pass around the loop. How could we start that process? Let's first think about what variables do we need?
I or J.
Let's try to name things as specifically as we can, just with a problem that's has this few variables, it's probably easy enough to keep track of them if we use single letter names for things. But whenever possible, I really like to be able to name them something that's gonna be memorable, make our program easier to read. When we come back to this in a couple weeks and just look at what we did, we should just be able to take a glance at this and go, oh yeah, that works because this logic.
You do like fib 1.
So let's see, we have. What do people name their variables?
IJ, really boring.
The real test is happening now. You don't know, but your grade heavily depends on what you've named your variables. I'm kidding, that's a horrible joke. So we can name them 1 ago and 2 ago, 1 and 2, but 1 and 2 kind of have.
What if
Some
it was
ambiguity.
2? Like what if 2?
I'm gonna name them 1 and 2 and some, since we're gonna need all 3 of those, right? We can
How
declare
about-
these all in the same line. What is the initial value of 1?
1.
Should it be? Because now 1 is gonna be the one that is 2 ago. Which is why I think the 1 name is very confusing.
Why
This-
did it, what fib 1? Just the first value of Fibonacci.
I'm gonna name them 1 ago and 2 ago to alleviate the ambiguity. So 1 ago is gonna start at 2. 2 ago is gonna start at 1, to say when we're looking backwards from the current 1, that's what we're going to consider. We also need a current. Or I guess maybe. I'm gonna start them both at 1, and that way we can set the current to 2. Let's try that. We can check the value of current, and now current is going to be the first Fibonacci number that is even. So I think this will help our logic flow and make fewer edge cases that we're going to need to consider. So what is the termination condition for our loop? Should we use a for loop or a while loop here?
Thinking while maybe because as long as the total number is below 4 billion and I know number.
Yeah, we don't really know how many iterations of the loop we're going to need to get to that. How many Fibonacci numbers are there below 4 million?
A lot.
We could write another program to figure that out, but we don't know it while we're writing this program. So that gives us a hint that maybe we want to use a while loop instead of So what is this while loop going to contain? What's the logic inside of this loop, the termination condition?
Is less than or equal to 4 million.
Should it be some? We want to look for all of the even Fibonacci numbers that are less than 4 million. So what is going to reach 4 million that tells us, all right, now we're done? Current, yes. Is 4 million within the bounds of what an integer can store because we stored current as an integer?
Isn't it like? For like it's like 256K something for maximum overflow. It's ridiculously huge.
It's about 2 point something billion. So 4 million is within bounds. We're good. What would we do if we wanted to store something that was greater than the integer's maximum value? Does anyone know what that would look like?
When we have problems.
We would actually probably get away with using a long. And if you do this, then you would want to just put the letter L at the end of your number, and it would say, represent this, instead of being an integer, represent it as a long, which you can then store inside of a long. We don't need that for this, but just to let you know that that exists. Everything's an int, it's within bounds, we're not gonna run into that issue. What do we want to do inside of this while loop? So we already know the value of current. So we need to calculate the new values of everything, but not quite. Eventually. If we didn't know exactly what sequence to do, one thing I like to do is just start writing English comments in code and then filling in those English comments with actual code. So maybe we could say something like, we want to check if current is even. If so, add it to sum. Great. After that, we need to update values of 1 ago, 2 ago, and current to be the next fib number in preparation for next loop pass. Oh, that is wordy, but hey, it will work. Does everyone also know the shortcut for commenting and uncommenting large sections of code?
Isn't it a /* block of text *//?
You can do that for block comments, but let's say I just highlight all of this. Can I uncomment all of this all at once? Control //, yep. Turns it on and off. Super useful. Will again save you a little bit of time. It doesn't put it in a block comment, but these comments are going to be temporary anyway. I'm going to be deleting them momentarily. So just keeping them like this makes that just a little bit easier. All right, excuse me. All right, how do we check if current is even, and if so, add it to sum? If current mod 2 is 0, then we want to add to sum plus equals the value of current. That will add the value of the current Fibonacci number to the running sum, which is what the problem is asking us to do. So I think that is good. After I've implemented this and I think it works, I should test it. It's right, so I'm not going to for the sake of time, but I can delete this comment. Now I look at the next comment that I wrote, update values of 1 ago, 2 ago, and current to be the next Fibonacci number in preparation for the next loop pass. Great. How do we want to do this? Here's where we can start making mistakes. So what order do we want to do this in? Because we might find ourselves trying to override something that we're eventually going to need.
Just 1 2 plus 2 ago.
So that already has, we already have 1 plus 1 is 2. So that would replace current with current.
Wait, we'd have to change the who ago's value to 1 ago, who ago's value to be updated.
Yeah, so we want what is currently 2 ago, we don't care about that anymore. That's just gone. That's out of our minds.
Can we have a temp variable to keep for sanity, have a temp variable before you conduct the swaps?
Maybe. Maybe it's necessary. We could try it that way. 1 ago, though, is going to become 2 ago. The value of current is going to become 1 ago. But then we need some way to calculate what the new value of current needs to be. Let's see if we can do this. So what is the first line I should write to accomplish that? Great. What comes next? Current equals what?
So. Or no, would it be 2 ago? Why do you want?
Let's think about this by looking at the actual Fibonacci sequence. I don't want this pen, it sucks. So we have 1 and 1 and 2. These are the old values of 1 ago, 2 ago, and current. So we want to take 1 ago and move that over here. We want to take current and we want to move that over here. We've successfully done that. We now need to calculate the sum of whatever the new values of these variables are. This is where it gets a little bit confusing, because you don't want to use the old mappings of 2 ago and 1 ago and current. You want to use the new mappings of this. So let's actually write, this is now 1 ago. This is now current. Other way around. This is why you draw things out. We want to move this here, we want to move this here, we want to move something where we calculate something to get something else. So we wanted, this is now 1 ago, this is now.
Would that be sum?
So the sum right now just has the value of 2. There's a separate location somewhere, some
Well, some would
storing
be,
2.
some would be,
Oh,
okay, yeah, I think any temp variable will keep track of all this.
Do we need a temporary variable here?
I'm starting to get lost already. Well, temp variables for the help.
I was just thinking.
So 2 ago is the old value of 1 ago. So this is the new 2 ago. This is the new 1 ago. So what should the new value of current be?
3.
Which is going to be 2 ago plus 1 ago. Yeah, we want to sum these two new things, the new values of 1 ago and 2 ago, to get current. So 1 plus 2 equals 3, which is the new value of current. Now they should be prepared for the next pass through the loop. Since we modified current, it's going to be a larger value than it used to be. So we're gonna test this against, is current now less than 4 million? When we do this for the first time, the answer is absolutely. It's going to be less than 4 million, and it will be for quite some time. But you see that this logic is going to continue as we move 2 ago up to here, 1 ago up to here, and current up to here. And now instead of having plus here and equals here, we're kind of shifting the plus and equals as well. So now we have plus here and equals here. So we're just going to be shifting the partial expression from this sequence as we generate the next term, shift, generate the next term, shift, generate the next term, shift. Anything else we need to do? What else? What's the next thing to do in the code?
Right.
Print it? We think the loop's complete? Have I
No,
done everything?
no, we should print it when the whole loop's done, so outside of the loop.
Yeah, that seems like a solid idea. After the loop finishes, print. What are we printing? Some? I like that. Do we think this is gonna do it? Are we done? Anything else that we need to think about or consider? It's gonna work. So if we run it, we get something. Does this pass the sniff test? 4.6 million. Does that seem like this, just logically, the sum of the even value terms of the Fibonacci sequence up to 4 million? We would expect it to be something either approaching 4 million or a bit bigger than 4 million, just intuitively. Plug it in, see if it's right.
That's a big number. I'm not doing math in my head.
So we got the green check mark, it looks like. So this program is complete. Wherever possible, try to come up with some kind of visual, something that helps you understand what is this loop, what is happening here. I think just being able to see the shift that's happening here and seeing the movement that's happening within the Fibonacci sequence helps you to understand how this ties to this logic. If you understand this, you will be able to throw this together with much less effort than if you're just trying to do it all in your head.
Wait, this is ellipse, and then a light, what is the dark mode? It looks like people, huh?
It's light mode so that it's easier to see for everybody else in class. I prefer dark mode too. I'm in just as much pain as you are.
I didn't believe those ellipses look that one closely. The only diagram is the only thing that's that light.
All right, we are out of time. Have a great weekend. I will see you all on Monday for unit testing. Yeah, at least for the first half of the, from the first half of the course, we'll do this every Friday.
Still stacks, right?
Excellent. Yeah. Yes, yeah, we can talk that. I just.
So bright.
Oh, your weekend.
You too, take care.
You never write it. Oh, you said. Yes.